Hello, seventh grade. Let's solve some word problems. These ones are going to require that you use a little critical thinking, but they're actually really fun to set up and solve, believe it or not. I love these kind of math problems. And they're really, the whole critical piece is going to be figuring out one little part of the puzzle, and then everything will fall into place. So let's see what we're talking about. This is lesson 7M3, lesson 8, some supplementary information, questions that are like the problems that we're going to do in class, not exactly the same ones. So let's take a look at what these problems kind of look like. In one case, we're going to talk about a problem with a garden. So let's start off with the garden problem, the garden problem. And in this problem, we say 1/3. So we're trying to find the size of the garden. And we have some interesting information. So we know that 1/3 of the garden, and you may be able to solve this one by inspection, but we're going to do it with algebra because you can't do the next one without a little bit of algebra. 1/3 of the garden is tomatoes, and this is the size. 1/3 of the size of the garden is tomatoes, and then we're going to do 1/3 of garden is peppers. And rather than know the last piece, we're going to say the rest of the garden is 12 square feet. And contains peppers. Now the strategy for this one and the next one is going to be to say we're going to make a bar. We're going to use bars to represent the size, and then we're going to make smaller bars to represent known pieces. Okay, so what does that mean? So let's make sense of what this. Then we're going to use critical thinking. That means use your brains. Critical thought to set up equation. And we've been doing this for the last couple classes, and you've been doing a great job. And then we're going to solve. And then we're going to check. So let's look at this. And once we set it up correctly, it's going to be really nice. So the whole garden, do we know how big the whole garden is? We do not know. So what we're going to do is we're going to draw a kind of a bar. And this is really piece one, where we say this is the whole garden. And we're going to call it X. We're going to call this whole bar from here to here. This is really, X. And we represent it here, but I'm writing it down here to tell you what X is. X is the whole size of this garden. So what do we know? I'm going to draw the next one in a different color. And we're going to say, well, we know that 1/3 of the garden. Now we're going to use some fractions. And we're going to say, well, 1/3 of this garden. And we're going to draw it in relative size, right? About 1/3 of this. It doesn't have to be exact. I mean, it could be a little bit longer. Whoops. That's 1/3 of the garden. 1/3 of the garden. So that if this whole thing is X, then this would be 1/3 of the X is tomatoes. So this will be our tomatoes. Well, let's just say the rest is, let's just draw it like this. So we got tomatoes and we got peppers and we got squash. So let's draw, so our second thing is we're going to draw some bars that represent, this is the whole garden. And then we're going to label the pieces. Label the pieces. Label the pieces. And then what we're going to do is we're going to start to use these numbers. We know that a third of the garden is tomatoes. So I'm going to redraw this one more time. Like this. And we know that a third of the garden is tomatoes. So that's a third of X, right? So if the whole garden is X, some number that we don't know, maybe it's 30. If we go from 30 to a third of 30, which would be 10, we have to multiply by a third. So we know that this is 1/3 of X. And we know that our peppers is also a third of X. So we're going to write that 1/3 of X. And we don't really know what fraction our squash is. But we kind of do know what fraction, because if the tomatoes are a third and the peppers are a third of X, then the squash must be the remaining third. So that'd be a third of X. And this is where we used our critical thinking. We looked inside the problem and we thought a little bit harder, and we said, well, that must be a third. Because 1/3 and 1/3, well, the rest must be a third. Now, the other thing that we know from the question, and let's make this, and we'll make this back in red again. We know that this 12 feet is the part with the, whoops, this isn't peppers, this is squash. And contains squash. So this must be 12 square feet. This last piece from here to here. Now, we can go about this two ways to solve. One is the algebraic way, and if we know that 1/3 of X is 12 square feet, we can do this. We can say 1/3 of X equals 12 square feet. And this is a one-step equation, right? So if our plan was, and we'll go back to what we were learning in class, 1/3 of X is 12. So if we know that we to get from X to this side, we take, we multiply by 1/3. To undo it, we have to divide by 1/3. So we're going to divide both sides by a third, divide both sides by a third, and on this side we get, those cancel, X equals 12 divided by a third is the same thing as 12 times 3, which is equal to 36. So our X is equal to 36 square feet. And remember, X is the whole garden. So our whole garden, if we're trying to find the size of the garden, we have our answer. X is 36 square feet. Now in this question, we also so this is method 1. But we could have used method number 2, which might seem easier to you. We know if a third of the garden is 12 square feet, then the peppers also are 12 square feet, right? If the squash was a third of the garden and the peppers are a third of the garden, they're the same size, so they must both be 12. And our tomatoes, in fact, must also be 12 square feet. So if this is 12 and this is 12 and this is 12 and they're all 12, then 12 plus 12 plus 12 is also 36 square feet. So our answer, either way, 36 square feet, whether we use kind of the algebra method or we kind of use this critical thinking method, where you kind of don't have to really do quite as much algebra, both work. But the whole key was to kind of draw a picture of the size of the garden and use our information to help us think about this problem. Again, this is not meant to teach you if you don't get this, if this is the first time you've heard it, don't feel too bad. This is meant to just kind of either if you're watching this video after we've done the lesson, it's meant to kind of refresh your mind and give you an example of a problem. If you haven't seen it yet, then this is just something that will kind of get your brain primed for the lesson that we're going to learn in class, where we're going to go over this in additional detail. So now let's try the other problem. This other problem is a little bit trickier, but I think you'll get it. You'll get at least parts, some of the principles. So let's make sure that we can figure this out. Let's do a little thinking. So the way that this works is we're at basketball practice, and you'll see that this is the exact same thing, really, is the garden problem. So we're at basketball practice. And we have 3 phases. And our 3 phases are, we're going to warm up and shoot. Then we're going to scrimmage. And then we're going to warm down with free throw shooting. So this is part 1, this is part 2, and this is part 3. And they're independent. And that's the entire practice. So, and the way that we do this problem is we're going to say warm up and shooting is a 1/4 of practice. The scrimmage is 1/2 of practice. And then we shoot free throws for 15. No, let's change that up. Let's change that to 20 minutes. So we're going to do free throws for 20 minutes. So the question is how long is practice? How long is practice? And you can see this is just like the garden problem, just a little bit more involved. Okay? So let's draw a picture. So basketball practice looks like this, and that's the entire time. This is the total practice. Now, a 1/4 of it is warm up and shooting. Then we go into a scrimmaging phase, and then we go into a free throw phase. So let's see. So about a 1/4 would be right about here. And so this is warm up. So that's warm up and shooting. Then we go, then we're going to go about 1/2 of practice, and we're going to call this scrimmage. And then in the final piece, we're going to do free throws. Now, doesn't that look about right? I mean, this looks about a 1/4 of the time. If we're running a clock, this would be about a 1/4. This would be about 1/2 of the practice, and then this free throws would be like the last piece. So let's write some more things in here. Let's see. Our warm up is 1/4 of the practice. Our scrimmaging is 1/2 of the practice, and our free throws must then be, well, if this is a 1/4 and this is a 1/2, well, this must be the rest of the practice. And if you want to think about it, you can say, well, 1/4 plus 1/2 plus what equals 1. Well, let's make these into a common denominator and say, well, 1/4 plus 2/4 plus what equals 1. Well, this is 3/4 plus what equals 1. Well, the answer is x equals 1/4. So the free throws must be 1/4 of x. Because that's all that's left over. It must be, right? 1/4 plus 1/2 plus 1/4. If I think of my pie, I could say, Well, this is 1/4 plus 1/4 is plus 1/2. That's your whole pie. So this must be right. Now, what else do we know in this problem? Well, we know that the free throws are also 20 minutes. Now we have two ways to solve the problem. We can do it kind of the smart and clever way, where we don't have to do too much algebra, but let's do it the algebraic way first. We know that 1/4 of x equals 20. So if a fourth of some number is 20, we know that x is 80. We can do it with more fancy algebra, but that would be 1/4 of x equals 20. Divide both sides by a fourth. Divide both sides by a fourth. That'd be x equals 20 divided by a fourth equals 20 times 4/1 equals 80. It's another way to get at your answer. So here I think that practice must be x equals 80 minutes. But the other way of solving the problem is basically to say, well, if a fourth of x is 20, well, warm-up is also must be 20. And then a half of x, if a quarter of x is 20, right? If this is 20 in our pie and this is 20 in our pie, then the half must be 40. So the scrimmage must have lasted 40 minutes. And 20 plus 40 plus 20 is 80 minutes. So, oh my goodness, you know what we forgot to do on our last one? Well, here we go. We got Happy Cat. Solve that one correctly. We got to go back to our other problem and open it back up and put our Happy Cat on this one too, because we solved this one when we got our 36 feet. Okay. Hopefully this was a useful exercise. We'll do some more in class. I just wanted to give you two more examples, ones that you could pause, slow down, had some color in it, a little more voiceover, and we'll see you in math class. Two claps? Okay, great. What's that sound? I'm scared. Let's get out of here.